So let us start today's class. We have compared the angular versus linear quantities of a body which is moving. So if you have linear movement, it will have the first column, which is distance, velocity, acceleration, mass, force, momentum, which are in linear quantities, and in angular quantity the corresponding terms will be angle, angular velocity, angular acceleration, moment of inertia, torque, and angular momentum. So for last one is kinetic energy. So here the kinetic energy of a linear movement of a body moving in linear motion will have half mv square, where v is the velocity and m is the mass of the body. But when the body is moving rotational, when it is having rotational motion, it will have kinetic energy instead of half mv square, it will be half I omega square, where m is replaced with the moment of inertia and v is replaced with the angular velocity. Linear velocity is replaced with the angular velocity. So the total kinetic energy of the body which is rotating, and it is along with the rotation, if it is moving linearly as shown in this picture. See the picture, it is moving right along with the rotation, it is moving right towards right with the velocity v. So if you have a body which is along with the rotation, if it is linearly displaced, it has both kinetic energy, linear kinetic energy, and rotational kinetic energy. So it will be total kinetic energy half mv square plus half I omega square. Let us now consider an example here. When you have a hoop, that means a ring, and a disc and a sphere of same radius and same mass are allowed to fall or slide through an inclined plane from top, which one will be reaching first on the bottom? So let us see the kinetic energy of these three bodies, hoop, disc, and sphere. The only difference here is the moment of inertia I. See that I is maximum for hoop, and then next value of I is for disc, and the lowest is for sphere. You can see it here because we have studied already the moment of inertia of a material having same mass with the same radius, but the different shapes have different values of moment of inertia. I will show it to you. We have earlier studied. This is here. See here, the on the top, the second one is the ring or the hoop, which has moment of inertia I is equal to mr square, where m is the mass of the ring and r is the radius of the ring, about which and it is rotating about the axis which is passing through its center and perpendicular to the plane of the ring or hoop. So about that axis, the moment of inertia is mr square. And let us consider now the disc. Here the disc can be considered here as a solid cylinder having a smaller thickness. So it will have a kinetic energy half mr square. So it will be smaller than the ring. And next one, the sphere, the last one, it will have again smaller value compared to the disc, which has 2/5 mr square. So if these three bodies have same radius and mass, which one has most moment of inertia? Hoop has the largest moment of inertia, and the smallest moment of inertia is for the sphere. So let us see which one will reach first. So the lowest moment of inertia will have highest velocities in it. So that is why that is because of that reason we can say that see here, the smallest moment of inertia, you can see the sphere, this blue one has half I omega, the smallest I is shown there. So it has smallest moment of inertia I. So that means it will have largest velocity. So it will move faster. Smallest moment of inertia body will move faster. So it will reach first. And the second one will be the disk. And the third one will be the hoop. So every sphere beats every disk, and every disk beats every hoop. Now one more example is written here. If all Earth's inhabitants moved to the equator, what would happen to the length of the day? So that means all the mass is going towards the center. Towards the center means it is moving out from the center of the Earth. All the mass is moved out towards the center. That means its moment of inertia is larger there. So that moment of inertia larger means the rotation speed will be decreased according to the conservation. When mass increases or moment of inertia increases, the velocity decreases. So the rotational velocity will decrease correspondingly. The angular velocity, if I increases, angular velocity decreases. So the rotational velocity of the Earth will be decreased. That means the day would be longer then. So that is the answer. So only this much is for angular and linear connection, the connection between angular movement and linear movement. Now let us see one more data, which is centripetal and centrifugal acceleration. What is centripetal acceleration and centrifugal? You might have heard about it in your 9th, 10th classes itself. When a body is rotated, when a body is moving in a circular path, it will have a force directed towards its center, isn't it? That force, in that direction there will be an acceleration, isn't it? So that acceleration will be centripetal acceleration. And what is tangential acceleration? It is the instantaneous linear acceleration of an object directed along the tangent to the object's circular path. So it is shown here in this picture, all these tangents on this blue figure. Those are the directions through which the tangential acceleration is directed. So tangential acceleration is always perpendicular to the centripetal acceleration. And what is now the centrifugal acceleration? Centrifugal acceleration is always opposite to the centripetal acceleration. See in this figure, in the below figure, right hand side, that white figure. Centripetal acceleration is always towards the center, and centrifugal acceleration is opposite to it. So as an object spins around fixed axis, there is a force that pushes that ball outward and tries to keep it moving out in straight line. But there is also a force that pulls the object continually back towards the center. So this towards the center, it will be centripetal, and towards opposite to the centripetal acceleration, there is another acceleration, centrifugal. So always an equilibrium happens, always a balance happens between these centripetal and centrifugal acceleration. Then only this body will be moving in that circular path. If centrifugal acceleration is larger, then always the radius of rotation will be increasing. So it will be moving out, it will be moving in a bigger circle. Always it will move out from the center. So if the centripetal acceleration, if it is larger, then it will move towards the center, and it will fall into the object will fall into the center position. So that is why always we say that always there is a balance. There should be an equilibrium between the centripetal acceleration and the centrifugal acceleration. So these due to the centrifugal acceleration, that is why we use roller coasters. So that is why we are not falling out from the roller coaster. When we have rotational motion, we are moving in a circular path with a very high speed, but we are not falling into the center. Why? because of the centrifugal acceleration or centrifugal force which is acting on our body toward away from the center of the rotation. That is why we are just sitting on the seat in the roller coaster. We are not falling into the center or falling down due to the gravity or that is why you can see that we can move up and we can move down. When you move up and down very fast due to the centrifugal acceleration, you will be sticking onto your seat itself. You will not fall. Because of this reason we are using these roller coasters. So we have actually finished our motion, the module of module 3 module, which is motion. So now we will be in the next class we will be studying your first module. A part of your first module will be taught by Abarna Miss and the other part will be taught by me.